Welcome back to part 4 of our real-time video compression app tutorial series. First of all, I want to give a massive thank you to each and every one of you who made it this far. Whether you have been with us since part 1 or you are just joining us for the first time, your likes, comments and messages have truly kept me motivated and inspired to keep building this project. If you are new here, my name is Izzy and I'm super glad you are joining us today. On this channel, we build real-world software engineering projects from scratch in a step-by-step approach. If you are watching this right now, that means you have successfully powered through part 3, and if not, I will encourage you to check out the previous episode of this tutorial series. In part 3, we built out the entire backend engine of our video compression application. Now let's take a quick trip down memory lane. In part 3, we were able to set up WebSocket communication for real-time updates. We got our course and all other necessary configurations implemented. We also handled our secure video uploads. We then integrated FFmpeg for powerful compression. We used multi-threading to manage background tasks efficiently, and we even added real-time progress tracking and the ability to cancel compression tasks on demand. In summary, we built the brain and muscles of the video compression application. Now in part 4, we are going to bring everything to life on the front end. This is where we are going to connect our Slick UI to all the powerful backend logic we just built. We are looking at a full integration process here. We are going to handle the following in this part 4. We are going to handle file selection, including drag and drop functionality. We will also connect our video compression API so that our users can start compressing a video by just clicking a button. We will also implement the task cancellation API so that users can easily stop compression process at any time. We are also going to implement a proper state management service to make the app feel smooth, responsive, and bug-free. We will also hook up our WebSocket to get live updates from the server. This part is going to be super rewarding because you will get to see how we bring everything together. I mean both the front end and the back end. Now don't forget to hit the like button because by doing so, it helps the algorithm show this content to others who might find it useful. Also make sure you subscribe to this channel and turn on notifications because this series is only getting better from here. Drop a comment below if you're excited about part 4 and if you have any questions, please don't hesitate to ask. I would love to hear what part you are most looking forward to. And if you know someone who is trying to learn full stack development or build their own file processing app, please feel free to share this series with them. Alright, so without further ado, let's dive into part 4 of our video compression app. We are going to start our front-end implementations by creating a DOM element.js file. We are going to be defining all our DOM element references inside a single file we will call our DOM element.js. We will then be importing them wherever we may need them in order to ensure a clean, scalable, and maintainable approach for structuring our front-end JavaScript code. Now, we are going to be getting these DOM element resources from our index.html page. By keeping all our DOM elements in one file, it will enable us to have a single source of truth for every element used across our app. So it is going to give us a centralized access. And with this, there will be no need to query the DOM multiple times in different files. It will also help us to follow the dry principle properly. I'm going to try as much as I can to follow best practices in this tutorial. Now let's dive into the implementations. We are done specifying all the DOM elements. The video input is an hidden file input for selecting video files. The upload bus is in charge of the drag and drop area for uploading videos. The compress button is responsible for starting a video compression. The cancel button cancels an ongoing compression process. The cancel container handles all cancellation controls. The new compression button is responsible for starting a new compression after completion or cancellation. Like when you finish a compression process, alright? So you will see a prompt, a new button requiring you or prompting you to actually compress another video. So, and this prompt can also come up after a cancellation process. The new compression after cancel button is alternative button to restart compression after cancellation. The status message will display the current status, for instance, compressing. So when the video is compressing, it will display this compressing message, like telling you that the video is actually compressing. The same thing will happen if you try to cancel a video that is already compressing. The file info will show file name and file size after upload. The file path display will display the uploaded file path or name. The original size will show the original video file size. The size reduction display will show percentage of file size reduction after compression. The cancel file name, cancel original size will display the file info during cancellation confirmation. The progress bar for the progress test will show visual progress bar and percentage test. When a video is being compressed, we are using the progress bar to actually show the status of the compression process. All right, so if it is like maybe 10%, the progress bar will be updated accordingly. The compress spinner will be in charge of the spinning and animation during processing. The compress test is a test label for compression action. The success container is a UI shown when compression is successful. The video preview is the preview element for the uploaded video. When you upload a video, all right, for compression, this video preview will allow you to actually preview the video, all right, before you start compressing the video. Finally, the video container is a wrapper or container for the video preview. So that's it for our DOM element.js file. Now the next implementation we are going to look into is creating our compressor.js file. The compressor.js file will be in charge of managing the full video compression workflow by coordinating file selection, compression initiation, real-time progress handling, and cancellation. We are going to be handling file and job ID tracking and also communication with the backend through a custom API service that we are going to create. We would also ensure proper UI updates in this service via another custom service that we will create, and also via a couple of utility functionalities we are going to implement. Now, the main responsibilities of the compressor.js service will be to start a video compression with proper state and form data setup, to handle cancellation requests and abort ongoing tasks, to manage file selection and drag and drop interactions while updating our UI states. Having said this, let's start implementing the first set of functionalities. But before we dive into the implementations, I would love to give you a clear understanding of the functionalities that we are about to implement and the roles they will play in our video compression process. The first set of functionalities that we are going to implement will handle the initial file selection process in our video compression app. This will also allow for file selection, correct UI update, and proper preparation for the video compression process. We are going to create methods such as handle file select, which will be triggered when a user selects a file via the inputs. This handle file select function is also going to log the selected file and store it in our custom state service, which we are still going to implement. We are also going to create our state management service. We'll call it state service.js. The state service is going to act as a centralized state management utility that will be used to track and persist key application data across sessions in our video compression app. The state service is going to handle several responsibilities such as managing current compression states, storing the selected video file and its metadata, tracking whether a cancellation has been requested, holding the abort controller in charge of cancelling ongoing compression tasks, persisting important states to local storage for recovery after page reloads. And also, the state service is going to have properties such as current job ID, which is the ID of the current compression task, cancel requested, which is going to represent a Boolean flag indicating if cancellation was requested, current compression abort controller, which will act as a controller that will be used to abort an ongoing video compression process. Selected file, this will represent the current selected video file with all its metadata and content. Original file size, this will contain the size of the original video file before compression. The state service will also contain some key methods, which will be mainly getters and setters method. We will also have another method called process selected file, which will be in charge of validating the selected file, updating the UI with the file details, and also setting up the preview. The method will also be in charge of waiting until the state confirms the file is stored before verifying button states. Another pertinent method method we will implement will be called update file info, and this will be in charge of displaying the video file metadata such as the video name and the size. The method will also ensure that file size is properly formatted. We are also going to have a method called setup video preview that will allow us to set up a preview of the selected video using a blob URL. This method will adjust video display based on aspect ratio for better visual, and it will also enable the compress button once a valid file is selected, not minding the size of the video, whether the video is in a 9/16 ratio or maybe like a 16/9, or no matter the ratio. All right, so this method will help us to ensure that this video standard size. Then finally, there will be a function that will help us to always verify the compress button state. This method will ensure that the compress button is only enabled if a file is selected and no cancellation is in progress. So this will help us prevent invalid actions by checking application states. So we want to ensure that if a file is not selected, we don't want the compress button to be active. So it is only when we select a video file that we want to compress, that is when the compress button becomes visible and becomes active and becomes clickable. So those are the functionalities that will make up our first set of implementations. We are going to create all the needed or necessary services that will be required to house each specific unique function as we progress with the implementation process. We want to try as much as possible to separate, consign, and maintain a single responsibility in each service. So we want to ensure that each service is handling a particular responsibility and it is actually doing it very well. So we will try to implement those functionalities that we have just mentioned. All right. So what I will be doing is that I will explain what the functionalities we do, then I will go into the implementations, because I just want to try as much as possible to save time. So let's dive into the implementation.
you
you. Now let's look at how everything works together. When the user selects a video, the file is captured and logged. Its information is displayed in the UI. The information of the video that we want to compress, like the name of the video and the size of the video. After that, the preview is immediately generated. All the button interactivities are updated, like all the buttons that we need for the compression to be performed. Like immediately you select a video, all right, that you want to compress, the compress button immediately becomes active based on the current state of the application. So our present implementation is very modular, and it follows the single responsibility principle. We have also relied on states to keep track of our application processes. Now we need to create another functionality that will manage file drag and drop and visual feedback in the video compression app. The method will handle file drop event on the upload box and prevent default behavior and stop event bubbling. We will name the method handle drop, and we are also going to have another method under the hood called handle drag leave, which will reset all visual stylings and capture the first file that the user dropped into the compression UI. What this means is that if a user drags a video into the UI of the video compression app, that video is captured. If a user drags another video on top of the one that is there already, the new one that he drags, all right, into the UI will be captured, all right, then the other one will be deleted. So the one that will be captured will be the latest one that the user drags into the UI of the video compression app. So that's the goal here. So the method will ensure that the file gets saved in the state service if the file is valid. So we also call the show status function to display a status message to the user, which could be a success or an error message. Now let's dive into the implementation.